In this video, we will look at some more basic introductory concepts involved in trig graphs. And so in no particular order, if you have something that is undefined, it's just where the LCD, the lowest common denominator, is 0. So maybe they've asked you to sub in 0 into a point, but you notice that the x is at the bottom, and so it will make it undefined. Visually, what will happen there in a graph is you'd have an asymptote. So in a typical tan graph, if I put in 90, then I get an asymptote. Why? Because tan is sine over cos, and if I put in 90 for cos of 90 is 0, and so you end up with a 0 at the bottom in the LCD, and that's why it's undefined. That's why you get an asymptote. If something becomes a fraction, like tan, it really helps and makes your life easier to put the other terms immediately over 1. And so if this was a question in graphs, my first step would be tan is sine over cos. And to avoid confusion in writing just cos here, like most people do, and then maybe you think it's cos squared at the bottom, because cos was over nothing, just put it over 1, because then it makes it easier to see where to cross cancel. If you have a graph that's shifted to the right, so plus 40, then the bracket that gave you that would be minus 40. So if I gave you a graph and I said, which way is this shifted? You'd say, what comes out of here? It's minus 20, so it's gone 20 to the left. If they ask you increasing or decreasing questions, just look at the graph and treat it. Here's a basic parent cos graph. Just treat it like a roller coaster. We normally read from left to right, and so get on your roller coaster on the left and just see which way it's going. And so if this basic cos question said, where is it increasing? You'd say, oh, it starts here at 180 and it keeps increasing until 360. You never say exactly or equal to, because you can't say at the bottom or the top if you're increasing or decreasing. So where's this graph increasing? It's just where x is somewhere between 180 and 360. Another left field way to ask your increasing, decreasing question to put in a curveball is just to say, where is the derivative bigger than naught? You don't have to actually do derivatives of a sine, cos, or tan graph. You have to just interpret derivative as being the gradient, and the gradient being bigger than naught in English just means where it's increasing. So don't panic when you see those. Sometimes a question that they may be asking you is written all diamakar, which means in a confused way, but actually they're trying to hint you back to the original. So let's say you've been working in a question and this is what you had right in the beginning. You're about 3 or 4 questions into the question, and so just imagine this is being stored right at the top. You haven't thought any more about it, and they start asking you to work out using your graphs where cos is greater than a sixth. And it doesn't really seem like there's any connection, but these type of questions usually with inequalities refer back to the trig graph, and so you might just play around and realize, okay, if it was the original graph, then what would that have been? Okay, so I would have taken this across and I would have divided both sides by 3, and that actually is what they're asking. So actually, what were they asking? They were asking where the original graph was bigger than naught. They were actually in English just asking where the graph is above 0. And so I can go back into my picture. I know this is not the same exact graph, but just for reference sake, so if that was the case, oh, it's just where the graph is above 0. So that would just be there, and then I can write my answer straight from there. So look out for those inequalities that feel like they come out of nowhere. They typically are a rearranged version of the original. Try avoid subbing points with a 0. It's not the end of the world, but sometimes if you sub in a coordinate like this, 90, 0, if you sub it in, at times it can kind of wipe out the whole question, because you end up with this function equaling 0. So just look out for that. If you feel your question gets completely wiped out, you probably need to look for another point to sub in. Usually for points of intersection, if they ask you where do two graphs meet up, then what they're asking you to do is, for starters, making the one graph equal to the other. But typically solving for x now in trig graphs, we're doing it by the method of general solution. And I'll do a whole bunch of videos to tackle all the different ways that you could do general solution, and how matrics often do worse than grade 11s because their brains get so tuned in and excited with double angles and compound angles. And then the last thing is, you must put the starting and ending coordinate, even if they're weird decimals. So if you've used your calculator to enter in all your coordinates, like I typically do, you might find that the first point that they're asking you to draw is something weird. If that is the case, you do need to still write it because it's the starting or the ending point. Otherwise, if I get weird decimals for all the other points along here, I leave out all the weird decimal ones. I hope that you find that interesting, just some of the concepts of the basics of trig graphs. If you did, please like this video, subscribe to our channel, and share it with your friends.